AS-Level Trigonometry Exam Preparation Questions Part 3. Let's look at another example. Example 3. Prove the identity 1 over cos x minus tan x squared, and that is equal to 1 minus sin x, 1 plus sin x. Okay, so first we are going to prove that that 2 is equal. So let's just make it a little bit bigger. So it's showing you identity there. Okay, so start with the left-hand side. So just take one side. So if it's going to be square, so I take tan and I break it up into sin and cos. Then I make the denominators is already the same. I just put it on top. Then I square the top and I square the bottom, the numerator and the denominator, and I get this. And then I'm just going to, in the place of cos squared, I can put 1 minus sin square x. Then I write this bracket out 2 times, and I write this bracket only once. Okay, let's just say, let's just see 1 minus sin. So this is going to a difference between 2 squared. So it's like, it's 2 brackets, one with a plus, one with a minus, and then 1, and then sin x, 1 plus sin x. So this is difference between 2 squares, that step. Okay, and then this is cancelling out, so this is left, and then I can see that the left-hand side is equal to the right-hand side. Okay, so they let me first prove it. Now they go on and say, hence, solve the equation. Okay, so if I look, I see that this is the same as this. But in the place of this, I can now write this. So if you see what I'm doing, I say, if this is equal to this and this is equal to this, then basically I can just say that this is equal to this. So I can say 1 minus sin squared, sin 2x, 1 plus sin 2x equals a third. And then I'm just going to cross multiply. Okay. So I'm going to cross multiply. So I'm going to get that, and then I multiply. Then I take everything to one side. And now I'm just going to say, okay, so this is going to be 3 minus 1, so it's 2, minus 4 sin squared x, so sin, and that is equal to 2, and I divide by 4. So it's going to be, I didn't show you that step. I don't think it was necessary. I'll just show it now to you. So it's divide by negative 4, and I divide by negative 4, and then it's going to be a half. Okay, so basically, if I look at my domain, let's just go back to my domain. Now I see the same. This is 1x, and this is 2x. This is pi, so I'm in radians. So I'm just going to take my domain. I did it here. I multiply with 2. So instead of just 1 pi, just a half, it's going to be the full one. Okay, but now comes that special angles. So if I'm going to look, so if I say a half. Now, if it's a half and I'm sin, so sin, if I stand there, can I show you better? If I stand there, and I say sin is opposite over adjacent, opposite over hypotenuse, opposite, then it's working from this angle. So instead of saying a half, I can say pi over 6. Are you with me? So I can say 2x, so 2x equals pi over 6. 2x equals, okay, so that is what I did there. And now I'm just going to say, okay, but I know it's in the first quadrant there, and I know in the second quadrant. So the first one is just pi over 6. The second one is going to be pi minus pi over 6. I divide 2, I divide 2. So the solutions are pi over 12, or x equals 5 pi over 12. Okay, that's working with the special angles. That's bringing in a lot of things. Okay, I want you to stop the video, and I want you to do Trino free number 1. You can continue the video as soon as you are finished. And after that, you can do 2 and do exactly the same. Let's start with the first example. Example 1. Prove the identity that this is equal to this. Now, I always first like to write it down. So if I start on 1a, I'm first going to write down the whole identity. Okay. And then that's identical to 4 tan x over cos x. Okay, so let's start with the left-hand side. So if I look at my common denominator, it's going to be 1 minus sin x and 1 plus sin x. So I'm going to multiply there with 1 plus sin x, and there I'm going to multiply with 1 minus sin x. So if I put this in brackets, so it's 1 plus sin x, and I multiply with this one, so 1 plus sin x minus, put this in bracket, 1 minus sin x, and I multiply this with this denominator, 1 minus sin x. And it's going to be over 1 minus sin x, 1 plus sin x, and if I multiply it out, it's that difference between two squares. It's 1 sin squared x. Okay, now let's multiply out this. So it's 1 plus sin x plus another sin x plus sin squared x minus bracket 1 minus sin x minus sin x plus, let's just move it a bit, sin squared x. And that is going to be over 1 minus sin squared x. Okay, now if I'm just getting this out, so it's just a long way of writing, but I can already say 1 plus, I can add this, so 2 sin x plus sin squared x minus 1 plus sin x plus sin x minus sin squared x, and that is over 1 minus sin squared x. Okay, and now if I simplify, so this is cancelling out, so this is going to be 2 plus another 2, so it's going to be 4 sin x, and then this is also cancelling out, and if I say 1 minus sin squared x, that is going to be cos squared x. Okay, coming from that identity. Okay, and now I'm going to break it up. So I'm going to, I just want to show you. This is actually standing for 4 sin x, and I can say this as cos x and another cos x. So it's actually going to be 4 over, okay, we can make it 4 sin x over cos x, multiply 1 over cos x. Because then that becomes tan, so it's 4 tan x over cos x. Okay, because I always look at what they want it to become. Do you see? They want it to become this. Okay, and now I can end up by saying the left-hand side is equal to the right-hand side. Okay, and now I can again do this. So if they come with the second one, they say hence solve the equation, and then they put this. Do you see? Can I just get the pen again? They have this, and now they just put this. So this two will basically be equal. Do you see? So I'm going, because this is equal to this and this is equal, I can put this. So I'm just going to make it a bit shorter. I think I'm first going to clean to have space. Of course, I proved that one. It's just a lot of writing. Okay, let's just see. Okay, so let's just move on. So basically, I can now go and say, as I said, I'm going to say that due to that this one and this one, I can go and say, okay, in number B, I can say 4 tan x over cos x equals to 8 tan x. Okay, so basically I can put this over 1 and I can then go and I can multiply it. So I can say 8 tan x cos x equals 4 tan x. I take everything to one side, so 8 tan x cos x minus 4 tan x is equal to 0. Then I can take out 4 tan x as a common factor. And I will get 2 cos x. And I'm going to say 2 cos x minus 1. So I'm going to put this, I can say 4 tan x equals 0, or 2 cos x minus 1 equals 0. So tan x is equal to 0. Can you see? Because divide 4. Or I can say 2 cos x equals 1. So cos x equals a half. So that's my two options. Now, if I'm looking at this, I can say it's x is between 0 and a half. So it's only in the first quadrant. Can you see? Now, if I'm going to look at the tan graph, let's start with the tan graph and see where is 0. Now, this is my graph. So it's there. You see, it starts there at 0. Okay, but now it's only up to 90. So it's going to be at 0. So the first one, I can say x is 0. Because it's there. It starts there. Now a half. Now, if I go to my special triangles, so always try to see if you can use your special triangles. If you see any of the values which is in the triangle, can I just show you? If you have the triangle, any of these values, then see if you can use it. If you see, for example, a 2, let me get my pen correct. If you see a 2, a 1, or a square root 3, any of that as a combination, as a fraction. Because remember, this is 60, so it's pi over 3. And this is 30, so pi over 6. So if I say cos a half, so it's adjacent over hypotenuse. So it will be from this angle. So I can say that x is equal to pi over 3. And remember that it's only in the first quadrant. So it's only this one, and which is pi over 3. So I can end up by saying, therefore, x is equal to 0 degrees, or x is equal to pi over 3. And that is going to be my final. Very brilliant example. Okay, make sure you can do this kind of examples. Okay, I want you to stop the video and I want you to do number 2. Again, the same. As soon as you are finished, you can continue the video. But first, always try to do it on your own. Go to the textbook. See if you can find an example more or less. Because if you conquer it on your own, you're going to just remember it longer. Okay, so let's start. Number 2. Prove the identity. So this is actually nice if they start like this, identities, because they break it up. If you can then not do A, then you can continue with number B, even if you were not able to prove. So then this is sin theta minus 1. I will show you now when I come to B. Sin theta and the identity. And this is actually a challenging due to that negative. I'll show you now. It's a bit challenging. I think we're going to use that special angles again, but for now, let's just clean it. Okay, so it's going to be 1 plus sin square theta. Okay. So basically, I'm going to start again with my left-hand side. Okay, we can go to blue. Okay, so my common denominator, now this is already going to be, I'm going to first just take it as my common denominator. Just take this one, and I can work with this one. So basically, I'm going to just multiply there with 1 plus sin theta, and there I'm going to multiply with sin theta minus 1. Okay, so let's just start. So it's going to be sin 3 theta, and it's going to be 1 plus the opposite denominator minus sin squared theta, and it's going to be sin theta minus 1. Okay, and it's going to be over my denominator sin theta minus 1, 1 plus sin theta. Okay, now if I multiply out and I start, I get sin 3 theta plus sin 4 theta minus sin 3 theta plus sin square theta. Okay, can I just show you here in red? If you're going to have sin, I could have already in the beginning. I cannot change this around because of the minus, but I can change this one due to the plus, sin theta plus 1. So basically this one, I can put the sin in front. And can you see it's again the difference between two squares? So it's sin square theta minus 1. But you can multiply it out, and I want to show you can multiply it out. Say somebody is saying, I cannot see it. So then make it sin theta minus 1 and multiply it out plus sin theta. So it's going to be sin theta, and this is going to be plus sin square theta minus 1 minus sin theta. So it's going to be sin square theta, that's going to cancel out minus 1, and that's what I showed you there. Okay, so let's just go back. So it's going to be sin square theta minus 1. Okay, and if I simplify this now, so let's just see, this 2 is cancelling out. Do you see? So I have sin 4 theta plus sin square theta over sin square theta minus 1. Okay, but now I want to do that magic trick. I want to change this. I want to change this to around, because in the identity, if you have, okay, let's just show you, cos square x plus sin square x is equal to 1. So it must be, the 1 must be first. So if I have cos square x, it's 1 minus sin square x. Do you see? So I want to change this signs. Now I can do that. I can do that. I'm going to keep the sin 4 theta plus sin square theta. But look what I do now. I put a negative here in front. And then by doing that, I can change this sign to a positive and this sign to a negative. Did you see what I do? Okay. Why did I do that? Because I want to come to the tan. I want to come to that. So basically, if I'm going to now, I'm going to have negative, just leave it in front. So it's going to be sin 4 theta plus sin square theta, and now I can have my cos square theta. Okay, and now I can break it up. I can say, okay, leave your there. So I'm just going to, doesn't matter which of it's in front or not in front, but I can then go, okay, let's just take out sin square theta as a common factor on top. So it's going to be sin square theta plus 1 over cos square theta. So I'm going to have my negative sin squared theta over cos squared theta multiply. You see, I was, because there's a multiply then that sin squared theta plus 1 over 1. I'm just writing it like this. And then it's negative tan squared theta, and doesn't matter if it's 1 plus because it's the same sign. So 1 plus sin squared theta. And if you go back, then you see, oh, this is excellent. I can say the left-hand side is equal to the right-hand side. It's quite challenging with changing that sign there and then keeping it, but that's where the negative comes from. Okay, let's do the final in this question. So that was a bit, again, you can watch it more than one time, the video, and to make sure that you will be able to handle that changing of the sign. Okay, but for now, we're going to continue with this question. Okay. So let's just see how we're going to continue it. Just want to clean. Okay. Okay, let's start. Number B. Okay, let's look at number 2B. So hence, solve the equation, then this is equal to this. Okay, now check. This and this is the same. Therefore, I can say that this is equal to this. Okay, so let's start by saying negative tan squared theta 1 plus sin squared theta is equal to, I'm just going to move it a bit, is equal to tan squared theta 1 minus sin squared theta. Okay, now I think the best will be to take this term to the other side. So make a 0 and then say tan squared theta 1 plus sin squared theta plus tan squared theta 1 minus sin squared theta. Okay, and now I'm going to take out tan squared theta as a common factor. So it's going to be tan squared theta 1 plus sin squared theta, and then plus, and you can put it in bracket, but it's not going to have an influence due to the plus. So 1 minus sin squared theta. So if I'm looking at this, then I'm going to say tan squared theta. So the brackets, you can almost ignore it, but this can cancel out. Do you see? So 1 plus 1. So what is this is going to be? I'm going to put a bracket there also rather than. So 1 plus 1 is 2. So I'm ending up with 0 equals 2. I put the 2 in front. Okay, now it doesn't matter. If you divide by 2, it's going to stay tan squared theta is equal to 0. Even if you take the square root of plus minus 0, it's still going to be tan squared theta is plus 0 minus 0. It's the same. It's 0. Now, if you look at the tan graph, now let's just go for the tan graph. Because don't forget, but it's not included. So 0 is not included and 2 pi is also not included. So if I'm drawing, I'm just going to quickly put it another line there. It's always good to recall the graphs. It's going to help you. So this is the and just get a curve again. This is going to be the graph from 0 there. And let's just, I'm struggling to get it from 0. And then the other one is going to be like this. And this is going to be like this. Okay, so this is going to be pi. And this is going to be 2 pi. And this is going to be 0. So it's going to be there at 0. And it's going to be at pi. But the only thing is now 0 is not included, because if there was an equal sign, it would have been included, but now it's not included. So this one is out, and the only one is this. So therefore, I can end by saying, therefore, theta is equal to pi, and that is the only solution. Okay, so let the sketches especially help you when you're working with 0 or 90 or 180. That's going to be more helpful than the course diagram. I want to end this video with 3 points. Point 1. All these videos refer to the y equals mx plus c textbooks, the number 1 mathematics textbook used in Namibian schools. For more information on these textbooks, visit the Straight Line Publishing website. Point 2. All y equals mx plus c to success textbooks are available in the NEET catalogue of the Ministry of Education. Schools can order these using their yearly budget for textbooks, with the process typically starting mid-year. Make sure your learners have a copy of the y equals mx plus c mathematics textbook used by the top schools in Namibia in front of them in 2025. A final point. If you are in the position, I want to encourage you to buy your own personal copy of the y equals mx plus c mathematics textbook. These textbooks are available at the following bookshops. Remember, success in mathematics comes from hard work, perseverance, and the courage to face challenges head on.